In this video, Embarcadero Chief Evangelist David I. takes you through a scenario where an application development and a database team use Embarcadero RAD Studio, ER Studio Developer Edition, and DB Optimizer to investigate and fix performance problems in a database application. Let's see what happens.
I'm getting alarm SMS messages and emails from the performance monitoring system that are being sent to the DBA team and development team, alerting everyone that the latest release of a critical business application and the underlying databases are grinding to a halt. One of the DBAs reports a periodic performance problem in the heavily used payroll application system. The DBA has captured a snapshot profiling session using DB Optimizer for the database server, and he's sending it to me. I'll take a look. I've loaded the snapshot profile and I'm looking at the chart. It shows a lot of CPU activity, so maybe the server doesn't have enough CPUs for the traffic that's coming in. But it also shows a lot of user I/O, so maybe there's something happening with the SQL statement that's part of the application. We can go down and look at the SQL statement. We can also see that that SQL statement is 96% of the database activity. So there's definitely a lot going on the server. Let me go take a look at my application code and see if I can see something there. I haven't been working on the payroll application for a while because I've been on different projects. But let me take a look at this code and see if I can see something. I've got a subset of the payroll query application that I used for my testing. So I've loaded that. It's got a main program, and it also has a unit test for the SQL statement. But since it's been a while since I looked inside the database, I need to go back and refresh my memory about the data model for the payroll system. So I'll use ER Studio, that's part of RAD Studio Architect, to take a look and remind myself of the tables and the relationships that this query is involved in. ER Studio allows me to reverse engineer the database so I can look at the tables that are involved in the payroll system SQL query. I can choose the tables if I want any of the system tables, the user views, and so on, so that I can zoom in on the tables that are part of the query. So we'll select all, choose which objects that we want. We'll just take all of them. So we'll finish and import, and it'll reverse engineer all the tables and objects that are in the database that I chose. And once we have that, we'll have the data model. So we'll let this finish and then continue exploring. This is a fairly sizable database. It's got 327 tables. Of course, in my SQL query, I'm only interested in 5 specific tables. So once this reverse engineer is done, I can zoom in on the tables that are part of my query. After reverse engineering the database, I can see the logical and physical model of the database. The logical model has more than 300 entities, and I can use the browser to look around and see the relationships. I can also go into the tables and look for the ones that are part of my query. So for example, the PS Pay calendar has got pay group and run ID. The RetroPay request table has employee ID. The RetroPay program table, see what cycles the payment cycle is, the jobs that employees work on, and the RetroPay earnings. And then switch back to further exploring my application to see where the problems might be. So back in the subset application, I can look at the SQL statement, go look at the code. There's other code involved as well, but I'm going to focus right now on the SQL query and see what might be happening. First, I want to make sure that my subset program still works, so we'll run it and see if the query returns a result. I can also activate the unit test for running the query that tests against a known development database that's a copy of a production database to make sure the query is returning the right results. We'll run the unit test just to make sure that everything's okay still as well in this subset application. And the unit tests fire and all is good. I reminded myself of the data model. I looked at the code, I ran the code and ran the unit test, and that all looks okay. So it's time to explore and profile the SQL statement inside the database to see if I can learn some more. So I'll use DB Optimizer to do that. So we'll connect to the database running in the lab. We'll open up a SQL editor. We'll go back to our application and we'll take the SQL statement and we'll paste it into DB Optimizer and run it. So I can look at its profile against the development version of the production database. And I've got one session, which is that SQL window hitting the database. The DBA reported, though, that it was under load, lots of concurrent users and processes running against the database. So what I need to do is use DB Optimizer's SQL load testing capability. So we'll click on the little clock here and do a SQL load using an ad hoc query, the same query. We'll do 10 executions and have 15 parallel sessions going on, and we'll just let them fire as they need to and see what the impact is on the database. Now notice we have lots of active sessions going on, and sure enough, under load, we're seeing the CPU beyond the max CPU line. This database server has 4 CPUs in it. But also notice there's lots of I/O going on in these SQL statements. And so what I want to do is figure out where the SQL is spending its time. I can also use the tuning part of DB Optimizer to take the SQL statements and see if there are other alternative SQL statements to use. And we'll execute the generated case. And after I execute each of the generated cases in the tuning session, I can expand the generated case and look for other options that will take less time. Notice the SQL statement I had took 2.47 seconds, but there's some queries that took much less time. So we can go and choose one of those and look at the SQL. This one is using some indexes. It's unnesting the nested select statements. Now I can go back into RAD Studio, take that tuned SQL statement, paste it into my application, and make sure that it still works correctly. We'll run the application, and it returns the same result for the same company. I can run the unit test and make sure that it also succeeds. And it's working. Now that I have a better tuned SQL statement, I can do an update to the payroll application and turn it back over to QA for final pre-production testing and deployment and get back to that new project. That's just one quick example of how application developers, database developers, architects, and database administrators can work together to find and fix performance problems in database-driven applications using RAD Studio, ER Studio, and DB Optimizer.